Hello. So today we're going to do our math lesson, and we're going to do 13.3. And the name of this chapter is called Composite Figures. So we're going to look at how to find the perimeter and the area of figures that aren't just squares and rectangles. They're figures that are made out of squares and rectangles that are a little bit more complex. And if you know how to find if you know the formula and the way to find the perimeter of a square and a rectangle, this is not that much different. It's just that the shapes are a little bit more complicated. Sorry, we have a person walking a dog across our sidewalk. Percy's taking issue with that. All right, so we're going to do 13.3, and I'm going to go ahead and fold my paper. Somebody's a little bit whiny, and it's not me. All right. So let's take a look at 13.3, and I'm going to go ahead and I'm going to screen share my camera. I'm sorry, he hears me talking and he thinks that like there's somebody in the computer that should be talking to him. All right, so I'm going to go ahead and I'm going to write my name on my paper. There we go. And we're going to do lesson 13.3. It's okay. It's just the computer. And we're going to do pages 218 to 221. Okay. I'm going to turn on my lamp on my computer because I think it makes it a little bit easier to see, for you guys to see. All right. Here we go. So our objective in this lesson is to be able to find the perimeter and the area of a composite figure by adding the lengths of its sides. So a composite figure is made up of different shapes. So you can see in this little picture, we have two rectangles, actually, a rectangle here and a little tiny rectangle off to the side. A homeowner wants to fence in this piece of land. He draws a diagram and labels it A, B, C, D, E, F. So they are asking us to find C, D, and A, F. So we know that this length is the one we don't know, and this length is the one we don't know. And so if we know some of these other lengths, we can use that information to figure out the missing lengths, right? So we know that CD is the equivalent of EF plus AB. And we know that EF is 3 yards because it says it right up here. And we also know that AB is 8 yards because it says it right there. So we know that 3 plus 8 is going to equal 11 yards. So we know that CD or DC is 11 yards. If we're trying to figure out AF, which is right here, we know that that is the same thing as BC, 12 yards, minus this 3 yards right here, minus ED or DE. And that's going to tell us what this measurement is. And that's 12 minus 3. So that's going to equal 9 yards. And then if we want to find the perimeter of the whole thing, we can add AD, BC, CD, DE, EF, AF all together. And that gives us 46 yards. Okay. So we're going to kind of walk through doing the perimeter of some of these composite figures. And one of the things I like to do is I like to draw the figure because I think it really helps you to understand what you know and what you don't know, what's there and what's missing. So I'm going to look at number 1. And I think if we're going to page 221, we have enough room for us to go ahead and draw figure 1 right here. So I'm going to write a number 1, and then I'm going to go ahead and I'm going to draw this figure. And it looks kind of like a rectangle that has a long skinny rectangle at the bottom of it. So I'm just drawing a smaller version of it. And again, it does not have to be perfect. It doesn't have to look exactly like the one in the book. You know, as long as you can use it to figure out what measurements are missing, that's what we're looking for. So we're going to find the perimeter of A, B, C, D, E, F. Okay. And the problem is we are missing a whole bunch of numbers, right? So in order to find the perimeter, we have to figure out some missing numbers, or at least one missing number that I can see. So the length of this piece is 16. The length of this piece is 9. The length of this piece is 4. The length of this piece is we don't know. The length of this is 3. And so one of the things that we kind of need to know is this length right here, because this is missing too. So one way we can do that is we can look at this total length is 16. And if this is 16 and this right here, if this length is 4 and this is the whole thing, the total 16, we can take 16 minus 4, and that's going to tell us CD. Okay. So we're going to say CD equals 16 minus 4. And so that means CD is going to equal 12. And these are all in meters. So 16 minus 4 is telling us CD. Now, we don't know this one right here. We do know we're looking for BC. So BC is going to equal 9. 9's the total length. And then this length is 3. So we're going to say 9 minus 3. And that means that BC is going to equal 6 meters, right? So now we know that this one right here is 12, right? We know that this is 12. And we know that this one, we know that BC is 6. So now we can figure out the perimeter of the whole figure. And the way that we do that is we go ahead and we write the formula for perimeter, and that is perimeter equals side plus side plus side plus side plus however many sides that you have, okay? So let's look at how many sides we have. We could say P equals 4 plus 6 plus 12 plus 3 plus 16 plus 9. Right? So that's going to be the total of our perimeter. So I like to chunk these together. I didn't chunk that very well. And that means that I end up with, let's see if I have a little bit more room, I can put that over here. So that means I end up with perimeter equals 10. First chunk is 10. 12 plus 3 is 15. 16 plus 9 is going to give me 5, 25. Uh-oh, I have, just going to double check this. Yep, 25. So that means I end up with 25, because 10 plus 15 is 25 plus 25. So P equals 50 meters. Okay, so that's pretty easy, right? The trickiest part is finding the missing numbers, I think. And then once you're done, you just have to do some addition. You have to add all the sides together. Okay, let's do another one, and I'm going to draw it right here. I'm going to draw the figure here, and then we're going to solve it over here. So this looks like stair steps. And we have one line right here. And we have one line right here. And then we have one here and one here. And then we're going up one and across. And up one and across. Okay, so it looks basically like that. And like I said, it doesn't have to be perfect. One of the reasons why I like to draw them is because if I draw them, I can kind of write on the figure what I know. And just like we talked about in the lesson I taught you last week, you can't write in your math book, but if you make a little sketch of it, you can write on your paper. So this is a little bit tricky. This is telling us in the book lots of information. So if we look on here, this is telling us how long each one of these little stair steps is. So instead of writing it here, I'm going to write it by each of the stair steps. This is also telling us this, this, and this, right? And then what I'm going to do is add them all together, and I'm going to add these all together, okay, so that I get the total lengths of the sides. So when I write this one, this is 16. This doesn't have any A, B, C, D. It doesn't have any letters on it. So we're just going to write 16. This is 14. This is 12 right here. This is 13. And this length right here is 12. So we know, I'm just going to double check those. So I have 12, 12, and 14. And then I have 16, 13, and 13 right here. Okay. Now, in order to get the totals, this measurement right here, they told us is 16 plus 13 plus 13. And so if I add those together, I'm going to stack them like this just really quick. So I have 12. I'm not very good at adding in the afternoon. 42. So this is 42. Now I'm going to add these over here. And these are 12 and 12 and 14. And I get 38. Okay. Now, in order to find the perimeter of the figure, these are all inches. So in order to find the perimeter, I'm going to say P equals, and I have to add all of these together, right? Every little piece, every little side. This has 1, 2, 3, 4, 5, 6, 7, 8 sides. So I'm going to add 42 plus 12 plus 13 plus 12 plus 13 plus 14 plus 16 plus 38. And I'm going to just break these into chunks because I like to make the addition as easy as possible. So if I take 42 plus 2, I get 54. If I take 13 plus 12, I get 25. If I take 13 plus 14, I get 27. And 6 plus 8 is 14, regroup. And oops, sorry, I'm writing it all up here. I'm so sorry. Regroup, and I get 4, 5, 54. So once I've added and I've chunked them together, I can go ahead and stack these. One option is to add these two together and these two together. So you could do that. P equals 4 plus 5 is 9, and 2 plus 5 is 7. So those first two chunks are 79. And then I have 7 plus 4 is 11. Regroup, and I have 5 plus 1 is 6, 7, 8. So then I add these two together and I get 8, 9 plus 1 is 10, regroup, and I get 160 inches is my perimeter. Okay, so we're doing a little bit of trickery to figure out if they have any missing numbers. And then once we do that, it's just a matter of adding the sides. And if you add the sides in chunks, it makes it more likely for you to have a correct addition problem. Sometimes when we're adding a whole lot of numbers together and we're stacking them, it's easy to make mistakes. If you just add a couple together at a time, it makes it more manageable. Okay, let's take a peek at number 3. We have a few more to do. We have, I think we have enough room on the back. I'm just kind of double checking to see if we have enough room to draw all of them, like draw it and then solve it next door. So I have a problem that looks like this, and hopefully I'll be better at keeping it on camera. I'm sorry, I'm kind of used to filming these at school and not here at home. So I'm going to take a line that looks like this, and it looks like a U on the top. So it goes like this, and it goes down, and then this goes up and up over here, and then this comes down here. So again, it doesn't have to be perfect. It doesn't even have to be, the only reason I'm using a drawing triangle is because I want it to be neat enough for me to read it. If I can't read it, that's a problem. Then I can't solve it. So I'm just keeping it just neat enough by doing it with a drawing triangle. Okay, so we have something that looks roughly like that. Here's what it looks like in the book. If you don't have your book with you, it looks like this. Okay, and they're asking us for the perimeter. So we're going to look and see what we know. We know that this is 3. We know that this is 3. If we know that this one is 3, we know that this is 3 because they're the same length. We know that this is 8. We know that this is 2. We know that this whole length is 10. And then we don't know this over here. So we have to figure out, we've got this, this, this. We need to figure out this. We know this, this. We need to figure out this. We need to figure out this. And we know that this is 3 because these two line up. So this guy's 3. And that means we can figure out this one because if this is 3 and the whole thing is 10, we can say 10 minus 3 is going to tell us this. So 10 minus 3 is 7, right? So we know this length from here to here is 7, plus 3 is 10. And then if we know this whole length is 8, and we know that this is 2, we can take 8 minus 2, and that's going to tell us that this is 6, right? And now all we need to figure out is this one. If we know that this is 10, and this is 3, and this is 3, that's 6, and 10 minus 6 is 4, so we know that one is 4. So we're just kind of doing a lot of algebra and a lot of, oh, there's a missing number. Let's take what we know and subtract it to figure out what we're missing. So I believe we have everything now, and we're going to make a big, huge, these are all feet. We're going to make a big, huge equation. Perimeter equals, and I'm going to start right here. I don't want to double up on any of them. So I'm going to start over here at 8. 8 plus 3 plus 3 plus 4 plus 3 plus 3 plus 6 plus 7 plus 2 plus 3. Okay, and let's chunk these. Chunk, 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 chunk. And then let's solve the chunks. P equals 11 plus 7 plus 6 plus 13 plus 5. All right, and now we can add these chunks together. So if we take 5 plus 7, that equals 12. And 12 plus 11 is going to be 23. So we're going to say P equals 23 plus 6 plus 13, which is going to equal 19. So we add those together, and we're going to say that P equals 9 plus 3 is 12. Regroup. 2 plus 1 is 3, plus 1 is 4, 42. And we said this is feet, right? So our perimeter is 42 feet. All right. So far, so good. Okay. Now we're taking it up a notch. We know how to find the perimeter. That's pretty easy. Finding the area is a little bit more tricky. We know the formula for finding the area is length plus width, or length times width equals area. So if you have a composite figure like this, these are two rectangles. So first we're going to find the area of rectangle A, which is length times width, which is 8 times 4, and that's 32 centimeters squared. Then we're going to find the area of rectangle B, which is going to be 10 times 3, which is 30. And then what we're going to do, we're going to add them together, right? And that will give us a total of 32 plus 30, which is 62 centimeters squared, because we're finding the area, right? So perimeter is the measurement around the outside, but area is the measurement inside, and we're measuring it in squares. So let's look at number 4. Number 4 is kind of walking us through the steps, and I'll walk you through those same steps. And she's telling us, I always look at the little kids first because they always tell us clues of how to solve something. So she's giving me a clue, and she's saying you can divide the figure into 2 rectangles like this. So you could go this way, you could have X and Y. And they're showing us 2 squares, right? So I'm just going to stick with the 2 squares, I think. But she's telling you that, hey, you can also use the rectangles. It could go either way. So first we're going to find the area of square A. Then we're going to find the area of rectangle B. And then we're going to add them together. And that's going to tell us the area of the whole figure. So I am going to draw the figure right here because I always like to do that. So I have a little thing that looks like this, A. And then I have B. And B runs right along the top. So this is going right here. And it's a little bit longer like this. This is good practice in drawing. So this is A. This is B. This whole length is 12. So from here to here is 12. That's a problem because we're going to need to know A and B separate, right? This is 8. This is 4. This is 3. And so in order to find out A, we need to know the length right here, right? We need to know this side and this side so we can multiply them. So, and you can use, if you aren't sure, you can use this and we can put it right here. And then with this, with B, we know this one and we're going to have to know this, right? So if I know the total length is 12 and I know that this is 8, I can subtract 8 from 12 and that's going to tell me this missing number. So I know that it's going to be 4. And now I can multiply A equals length times width. And I know that I have A equals 4 times 4. So I know that the area of A is 16. Okay. And we're looking at, we're looking at yards squared. Now I need to find this missing number. If this is 4 and I add 3 to it, that's going to tell me the total length. So I know it's going to be 7, right? And now in order for me to find the area of B, I know that B is going to equal length times width, the area of B, and I have 7 times 8. I should put 8 first because that's the length, and 7's the width. So B equals 56 yards squared. So I'm going to take this number and this number, and I'm going to add them together. And that's going to tell me that the area is 72 yards squared. All right, the area of both of those figures, the rectangle and the square, this is almost a square, but it's not quite a square. All right, woo! You ready for me to flip the paper? Okay, we're going to do a few more, 5 more to be exact, and then we'll call it Quitsville for a while. And then after that, we're going to do 222 to 223. And actually, I think 223 only has 4 problems on it. Okay, so we have 5 more to go. And again, I'm drawing them. We're finding the area. So this is number 5. And then we'll do number 6 over here. And then let's just do 7 and 8. Okay, we can add number 9 in on tomorrow's lesson. So I'm gonna, so that I don't get this off the camera, I'm gonna put it right here and fold it. So I'm gonna go ahead and draw the figure right here. I have a thing that looks like an upside down L. So I'm just using my drawing triangle. And this is gonna be a little bit longer. And this comes down here. Again, it's okay if it's not perfect. These are like actually kind of fun. They're like little puzzles, little algebraic puzzles, visual puzzles. I kind of like them, weirdly. Okay, so this is 6. This is 8. This we don't know. This is 3. This is 3. And this we don't know as well, right? So we don't know this, but if we know this whole length is 8, we can subtract 3 away from that, and that will tell us this one, right? So this one is the same thing as 8 minus 3 will tell us the leftover. And 5 plus 3 equals the total length of 8. This one right here, if we know the total length is 6, and this little button is 3, then we know that this one's going to be 3 because 3 plus 3 equals a total of 6. And now we're ready to do our problem, and we're ready to say P equals, and I'm going to start right here at the 5. 5 plus 3 plus 3 plus 6 plus 8 plus 3. Did I get all of them? Sorry, my text thing went off and it lost my attention. I should have 6, right? 1, 2, 3, 4, 5, 6. I do. Okay. So again, I'm just going to chunk them because I don't like adding big strings of numbers together because I make mistakes. I'm pretty fast at adding 2 together, but not at adding 6 together. So this is an easy addition problem. I end up with 8 plus 9 plus 11. And when I add 8 plus 9, I get 17 plus 11. And when I add those together, I get 7 plus 1 is 8, and 1 plus 1 is 2. So I get 28. And I like adding the ones, regrouping and adding the tens so I don't have to stack the numbers. I learned that trick from a 6th grader named Ryan. I started watching him work and he never stacked numbers. I'm like, that's a lot faster. I like that. Okay, let's look at number 6. Number 6 is a big, weird shape. It's like a T with a really skinny stem. So I have this big fat top. And this matches this. They look like they're the exact same length. And then it has a little teeny little okay, so it kind of looks like that, more or less. It's not perfect, but this is telling us that this length is 12. So this whole length is 12. This is 4. This is 6. This is 6. We don't know how long that little skinny thing is. This is 5. And this we don't. This is 4. And we know this is 4 because they're the exact same length, the one across from it. If you look at the picture, if you're looking at the picture, you can tell that if this is 4, this is 4 as well, right? So all we have to figure out is this little teensy number right here, because we know this is 6. And if this is 6, the other side is 6 too. So the one that I have to figure out, if I know that this side is 6, then this one is 6. And this is what we're missing right here. This is the missing number. I'm just using my colored pencil to highlight what we don't know. So if I know that this total length is 12, and I know that this part is 5, and this part is 6, and 5 plus 6 is 11, I can take 12 minus 11, and that's going to tell me that this is 1. This is tiny. All right, and now we're going to do oh my gosh, you guys, I messed up. We're finding the area on this one. We'll go back in a second and we'll find the area. So I thought we were finding perimeter. So we're going to go like this. And let's call this A. And let's call this B. And we're going to find, we did extra work on number 5, but that's okay. So we're going to find the measurement of A, the area, which I'm guessing would be 12 times 4. And 12 times 4 is 48. So we know that A equals 12 times 4, length times width. And so the area of A is 48, and that's feet squared. Okay, now if we're going to find B, we know that this is 6, and we know that this is 1. 6 times 1 is 6. So we're going to add this plus this, and we know that 48 plus 6, this is 14, and that's 54. So the area is 54 feet squared of both of them together. Okay, now your ding dong teacher did perimeter on this. You guys were probably yelling at your computers. So there are a couple of different ways you could do this. You could cut it like this and do 3 by 3. You could also cut it like this. I think I'm going to cut it like this because this makes more sense to me. If I know that this is 6 times 3, then I know that the area is going to be 18 of this top one. So A equals 6 times 3. A equals 18. And we're measuring it in miles squared. We'll just call this extra credit. Extra credit for a gold star for our extra credit. Let's find our gold here and give us a gold star. Extra credit. Woo. Okay. So now I need to find B. I'm not going to worry about the 8 because remember the 8's the total, but I'm going to take 5 times 3. So B equals 5 times 3. B equals 15 miles squared. So if we add 15 plus 18, then the total area is going to be, let's see, 5 plus 8 is 13, regroup, and that's going to be 33 miles squared. All right. So we fixed that before we got in trouble. Okay, let's do 7. Remember, we're finding the area. Don't let me forget. So I'm drawing this. This looks like an L. It's fairly simple compared to some of the other ones. So I'm just drawing, this part's a little wider. I come down here. I'm going across. I'm going across. And I have an L. So this is what I'm drawing. Here's number 7. 7, 14. 9, and then we know part of this. We know this measurement. So we'll decide how we want to carve it up before we find the missing numbers, because we might not need to find all the missing numbers. So if we know that this is 7 and this is 14, I can go ahead and go like this. And A is done, right? Because I have the length and I have the width. So A equals length times width. A equals 14 times 7. And I'm going to multiply those. 14 times 7. And I get 98. A equals 98. And these are meters. Okay. Now we need to find B. And we know that this is 8 because it tells us, but we don't know, and we know this is 9. But in order to solve this, we're going to have to know this, right? We need to know how long that side is. So if I know this is 14, the total length is 14, and I know that this partial length is 9, I can take 14 minus 9, and that's going to tell me that this is 5. And now all I need to do is multiply 8 times 5 to get the area of B. So I'm going to add 90 plus 48. And that's going to give me a total of the total area. I did that one off without even using the work area, equals 138 meters squared because it's area. All right. Okay, let's look at number 8. Number 8 looks like this. It's a flipped upside down T. So here we go. I'm going to draw it right over here. I have this. And really the secret key is to draw these, because when you're drawing, you're thinking. I know that as an artist, that the thought process gets started when you're drawing. And we have a kind of a weird shape. It's like a T. This is longer over here. It's kind of easier finding the area than finding the perimeter, I think. Now, I'm going to do this the obvious way. For me, I think just going like this and putting a line across here and calling this shape A and this rectangle B is the ticket. This is 6. This is 7. This right here is 3. This right here is 3. And this right here is 3. Which means this is 3. Okay, so when we find out A is going to be 6 times 7, right? So A equals length times width. A equals 7 times 6. A equals 42. And these are yards. Okay, so A equals 42 yards. Now we have to find B. Now we know that this part is 6. So to get the total length of B, we could take this 3 plus 3 plus 6, and that would give us the total length. And we know that 6 plus 6 is 12. So this was our missing number. So we're going to call this B equals length times width. We're just calling it B instead of A. We know that it's the area of B, and that's going to be 12 times 3. So B equals 36 yards squared. So we're going to add 36 plus 42 to get our total, because one is 36 and one's 42. And we get 78 yards squared as our answer. Okay, so I hope this wasn't too daunting for you. It's sort of a combination of a lot of things. It's a combination of algebra, because you have a missing number puzzle. That's what algebra is. And you also have geometry, because we're dealing with shapes. And you also have measurement, because we're measuring area and perimeter. So we're kind of doing 3 different math disciplines all in one, which I'm sure made the creators of this math book really happy that we could do so many different tasks in one assignment. All right, so I want to thank you for joining me. This is one of our last math movies, and I really appreciate all of you working so hard on your math. And if you are somebody that didn't really do your math this year, I really worry about you next year, because math each year builds on previous knowledge. And that's why our math book always, at the beginning of the chapter, it always says, this is what you should have learned last year, right? So if you haven't been keeping up with math, I really recommend working on math during the summer, because 5th grade math is fairly challenging. I used to teach 5th grade, and whenever we did math, kids would be kind of confused and dropping away, because 5th grade math is where math starts to get difficult. Most parents do 5th grade, most adults do 5th grade math to live their lives, right? To do all of the common things that we do as adults. It's 5th grade math. So when you start getting beyond into 6th grade math, sometimes your parents can't really help you. That kind of happened with me. My mom really couldn't help me too much with math. She cut off at about 4th grade math. And so it's really important for you to keep up and for you to do your work. And if you haven't been doing your math during this year, there's still hope for you. You can go ahead and work on it during the summer. Keep in mind, though, that there were a lot of people in the class that were doing their math. And so you're going to be competing with them. They're going to be doing really well in class. And if you don't work on it during the summer, you're going to be kind of frustrated when you get to 5th grade. So it's always a good idea. I know it's been difficult because it's a pandemic, and I know that we're all a little bit frazzled and frayed, but it's really important to keep up on your work. It's your job as a student. You're a pro, you're a professional student, and it's your job to do your learning, right? To learn every day. And one of the aspects of learning is that you have to put some work into it, right? To learn new things. So there's still time, there's still hope for you if you want to work during the summer. If you've worked really hard and you've kept up on your math, and probably during the summer, all you're going to need to do is practice your times tables a little bit, and you'll be fine. But if you haven't been doing your math assignments, I mean, I have a math workbook from someone that's in my classroom. So I know that that person isn't doing any of the math workbook pages. That's really sad. That means you're going to be really far behind in math, behind everybody else. So it's really important to keep up the good work and to continue doing your work during the summer if you weren't putting any effort into it during the school year. And so that's just a little pep talk for you, that 5th grade is difficult, but if you brush up over the summer, if you weren't really keeping up, work on it during the summer. There are there's Khan Academy. Also, you could use any of the spare pages in your math workbooks that we didn't use, and you could work on those, and that would help you practice. Or if you haven't been turning in math work, you could go back on my YouTube channel, watch any of the videos, do any of the lessons. They're still going to be on there all summer. So you can use summertime to catch up, since you were using winter time as your summer. You can flip it and do schoolwork during the summer. That's what I would recommend doing. All right. So thanks for joining me. And thank you to all of you that really kept up and watched all the videos and worked really hard. I'm going to wish you the best of luck with Teacher Lisa and Teacher Seth. And even when you're in 7th and 8th grade with Brett. When math gets really hard, don't come to me for help once you get into 7th and 8th grade, because math's really hard for me in 7th and 8th grade. All right, so I will talk to you later. Thanks for joining me.